Thank you, Sandrine, for the introduction. Let's start with this thought. If it was easy to change the way we eat, malnutrition in all of its forms, including undernutrition, overnutrition, and micronutrient deficiency, would have been eliminated a long time ago. Everybody would have access to affordable food and would be able to choose the variety and quantity to eat that would keep them in optimal health. This is the dream, actually, and the reality is that we have a food problem. Actually, there are a lot of people that are eating a lot of food and a lot of people that don't have enough food to eat. And the food system itself, starting from production to supply to consumption, is failing societies, human health, and the planet.
And so to this end, the Lancet Commission wanted to have this reference diet put together, which we will go into a bit more detail later on. So what we're here to present to you today, as Sandrine mentioned, is our perspective article that Brucia and I have written together, and it should be out very, very soon. It's the one that Isabel mentioned on the first day. And we're going to go through with you what our search strategy and approach was and how we sort of, as Sandrine mentioned, approached this quite big task of dissecting this reference diet. And we looked at it each in food groups because that's how the diet's presented. And finally, we managed to come up with what are the main limitations in the literature, so the field in general, actually, not just the diet, and our recommendations for the future, whether that be for the diet and for the field.
So the Eat Lancet reference diet was first proposed in early 2019 with two major goals in mind. First, to nurture human health by averting up to 24% of premature deaths, reducing the incidence of diet-related obesity and the incidence of non-communicable diseases. And equally important is also to improve the environmental sustainability by trying to achieve or help achieving the UN Sustainable Development Goals and the Paris Agreement by 2050. And this image here shows the recommendations of the Eat Lancet reference diet against the actual dietary intake throughout the globe. And what you can see is that there is, this diet should be largely plant-based, and depending on where you live in the world, there needs to be drastic changes in the way that we are eating. And to put it in broadly, there needs to be more than 50% decrease in the amount of unhealthy foods that we eat, namely red meat, sugar, and so on, and more than 100% increase in the healthy foods that we eat, like nuts, legumes, fruits, and vegetables. And this picture here shows a day's worth of what adhering to the Eat Lancet reference diet looks like. Now, these requirements were based on the above-mentioned health outcomes and scientific targets, and we at ILSI, together with the task force, wondered whether, in addition to that, cognitive health and brain health could also be one such scientific target to achieve by adhering to this diet. And so we evaluated whether the existing evidence base would help address this.
Great. So as we all know, cognitive health and cognitive function is a really complex process that starts from that we can impact this from early age all the way up to old age. With neural atrophy starting from around 30 years old, this is a gradual process. And also, as we know, there is a myriad of genetic and environmental factors that can contribute to our cognitive health and cognitive decline. These include things like socioeconomic status, education, and of course, one massive modifiable factor is nutrition. So like Brucia mentioned, the real aim for us is, so we have this Eat Lancet reference diet, which claims to be sustainable for human health, but is it also actually sustainable for our cognitive health, which of course is a huge aspect of an overall well-being?
And so to address this question, we conducted a comprehensive but non-exhaustive literature review to help formulate our perspective. And our search strategy basically combined the food groups that were proposed by the Eat Lancet reference diet together with our outcomes of interest. So that is cognition, cognitive function, and cognitive decline. We have consulted RCTs, meta-analyses, and large prospective cohort studies and regarded them as the strongest available evidence. And when those evidence were not present, we've looked at cross-sectional studies and small that are large or small scales. We've importantly looked only at whole foods, as that is what the Eat Lancet reference diet is encouraging. And we've restricted our search to healthy community-dwelling individuals, also in line with their own review of the literature, and those that are 2 years of age and older. Now, a little bit differently, and as we've learned throughout this conference, that the time point at which dietary modification occurs could impact cognition later in life. And so we elected to evaluate the evidence for each food group per age group throughout the life course. And so to qualitatively provide as qualitative but also as quantitative picture as possible of the literature, we have classified the evidence from harmful to beneficial, and we've gave them a score based on the strength of the available evidence. We've also indicated where there are mixture of harmful and beneficial effects, and also where there are lack of evidence and null findings or no effects.
Great, so we're going to start off the discussion with whole grains. Now, across the board, whole grains generally seem to be pretty beneficial, particularly in childhood and on executive function. However, as we get older, we actually see there's not much evidence about. It's really hard to draw a specific conclusion. What we do know is that while there hasn't been any RCTs that have shown a direct link between whole grain and cognitive function in old age, what has been shown multiple times is that whole grain consumption seems to affect cardiometabolic health in old age. And that is also then linked to cognition, so perhaps this is the mechanism that we are seeing within this relationship. But between young adulthood and middle age, we are unsure.
Looking at tubers and starchy vegetables, we have also were able to find only 2 studies in the literature of heterogeneous design and populations, one indicating a weak positive relationship in childhood and no effects in old age. However, both of these studies did administer the same amount of potatoes, specifically as was recommended by the Eat Lancet reference diet. And as you can see, in young adulthood and middle age, there's absolutely no evidence, which is quite surprising given the fact that potatoes are one of those staple foods that are largely consumed across the globe. So definitely more research is required in this area.
So it may come as no surprise that we actually see pretty good evidence and positive evidence when it comes to fruits and vegetables. The main issue we have here is that we do not know the quantities of anything that we should be eating that would be the most beneficial for our cognitive health. What is quite interesting about this, though, is that the Eat Lancet diet, reference diet, does differentiate between dark green vegetables, orange and red vegetables, and they recommend that you have equal amounts of each of those types. And in most studies that we found, particularly in old age, what they find is that the variety of fruits and vegetables that you eat seems to have much more of an impact on your cognitive health and cognitive function compared to the quantity overall.
In relation to dairy, there is a lot of evidence that indicate that the recommended amount by the Eat Lancet reference diet of 250 grams per day, which is roughly equal to 1 glass of milk per day, has positive effects on sustaining cognitive functioning, particularly in childhood and young adulthood. In middle and old age, this seems to be moderated based on the fat content and the dose. And so this could be something that could be taken up in the Eat Lancet reference diet, for instance, by recommending certain amounts or further teasing out the different types of dairy products for consumption throughout the life course.
When it comes to meat, again, you might not be surprised that the evidence is very conflicting. It's very, very hard to find studies that have differentiated between red meat and poultry. But what we do see is, although there is no evidence in childhood and young adulthood, in middle age and old age, red meat in particular, there has been some signs that it could be detrimental to cognitive health. But again, the amount we should eat is completely unknown.
In relation to fish, the evidence base does support that higher fish consumption in general is associated with positive cognitive functioning. And it's also in line with the amounts that are recommended by the Eat Lancet reference diet. However, when there is fish that is high in pollutants and mercury, then this tends to offset the positive effects on cognition, and therefore it should be avoided. And this is particularly the case in childhood and young adulthood.
Now with eggs, although surprisingly considering the huge media nutrition storm that eggs had a few decades ago, we actually could really find almost no evidence on eggs and their impact on cognitive functioning throughout the lifespan. The only thing we could sort of find and figure out is that actually just a moderate consumption of eggs, that was all that was said, a moderate consumption of eggs seems to be neither beneficial or detrimental in middle age.
In relation to legumes, in general, higher consumption of legumes is beneficial for cognitive functioning. However, this graph may not exactly depict that, and that is because so much of the research is done mainly on soy-based products, such as tofu, which actually tend to be detrimental in old age. As you can see, the Eat Lancet reference diet has differentiated between different types of legumes, such as dry beans, lentils, peas, chickpeas, and so on, but those have not really been extensively researched, if at all. So more research is needed in this area to kind of complement the reference diet recommendations.
And with nuts overall, pretty positive throughout, and all the used quantities within the literature does fit within the Eat Lancet reference diet. For example, most studies tend to administer 10 to 60 grams a day during their RCTs. But what we do find in the literature is that actually going above a certain threshold, maybe approximately 30 grams a day, is actually no benefit at all after that point. So perhaps if we keep with the sustainability thing, the reference diet is actually pretty spot on when it comes to nuts.
In relation to dietary fats, this is also a complex picture based on the types of fats that we are consuming. So in general, a higher unsaturated fat intake, such as unsaturated oils, is associated with positive cognitive functioning, specifically in young adulthood. In childhood, for instance, higher saturated fat intake is detrimental. In middle and old age, there seems to be the general picture that total fat intake is harmful for cognition, but as you can see from the color gradient, the evidence are rather weak in terms of strength, so more research is needed to be done in this area to make us more confident about the conclusions.
And finally, we're on to sugars and sweeteners. It may come as no surprise that generally it is seen that sugar and sweetener consumption is pretty detrimental to cognitive function, especially as we get older. The main issue we have with the Eat Lancet reference diet recommendation is that it was found that about 25 grams should be the upper limit of the amount of sugar that we consume, particularly in old age. And so it could be seen that the Eat Lancet reference diet is actually too high when it comes to sugar consumption. And of course, there is no evidence in childhood. I'm sure we can all agree that feeding babies sweets for research might be considered unethical. And so here we have the overall picture of what we found. This was our qualitative, non-exhaustive review of the impact of food groups on cognition throughout the lifespan. And as you can see by the quite large areas of white and grey squares, that there is a lot of work that needs to be done. This is not just in reference to the Eat Lancet diet, but as a field in general. If we want to be able to make these sorts of recommendations for specific food groups, there is still a long way to go in that respect.
So this brings us to some of the major limitations that we could uncover by looking at the literature. One of them is that it was quite difficult to actually decide whether the amounts in grams that were proposed by the Eat Lancet reference diet are met by the current evidence base. And this is mainly because self-reporting is happening based on recall-based food frequency questionnaires. And so in the future, using detailed food diary logging as opposed to recall-based food frequency questionnaires would be beneficial. And in addition, as we have learned throughout this conference, it's not really easy for participants to report accurately in what they're eating. So maybe in addition, measurements of biomarkers of food intake would be beneficial.
So as we've all seen throughout the past few days, we know that dietary patterns as a whole are really important, and there's lots of interactions between our different food groups. So in this respect, there is a stark lack of evidence when it comes to these specific individual food groups that we discussed today. Not only that, but there is also a huge gap in the literature where the food groups are actually seen across the whole lifespan. We can't answer that for any of them from childhood to old age. So what we would recommend is that actually systematically we need to investigate the effect of each food group on cognitive functioning. Of course, the golden standard for this is RCTs, which is a lot easier said than done when it comes to work like this. But the second recommendation we would give is to conduct more prospective cohort studies that include multiple measures of dietary intake throughout this person's lifespan. Finally, we would think it's very, very important that each food group within each age group throughout a human life course should be examined much more deeply.
So as you could tell by the general figure and the largely light gradient of colors, most of the evidence are actually weak in nature and primarily come from cross-sectional analyses that have addressed multiple outcomes. So what these studies tend to do is administer batteries of cognitive tests, and maybe one or two of those tests end up having an effect. And so we have an increased risk of false positive findings. And also because it's done at one time point, sometimes we cannot exclude the risk for confounding effects. And so to minimize the measurement error, we need to prioritize studies with repeated estimates, both of dietary exposure as well as cognitive assessment. And another way to do this is to use data from existing large-scale prospective cohort studies and to try to evaluate whether the food intake there is aligned or not with the Eat-Lancet reference diet. And I would like to bring in this example of a recent paper that was published in Stroke, which basically had data existing in 1993 to 1997 of over 50,000 people in Denmark, I believe, and they were followed up for 15 years and have been recording food frequency questionnaires. So what the researchers did was actually convert these values into a Eat-Lancet reference diet adherence score. And what they have found is that higher adherence to this diet based on this score was associated with lower risk for subarachnoid hemorrhage, but not other more common types of strokes. And interestingly, they also used the same data to devise an adherence score for another diet, the Alternative Healthy Eating Index of 2010, and that was associated with the other two more common types of strokes rather than the one that the Eat-Lancet was associated with. So this is quite complex data to make sense of, but I think such a step would help us immensely in trying to answer whether the sustainable diet is good for the brain. And if we can find such large prospective cohort studies that we can reuse and reevaluate and recalculate would be quite beneficial in answering this question.
So just to summarize everything we've discussed today, all we see is that, generally speaking, there's a very limited evidence of these effects of these food groups in chronic intake. So can we say that the Eat-Lancet reference diet is beneficial to cognitive health? I think the jury's out on that one. It seems like there's still a lot of work that needs to be done to really answer that definitively. But it really shows that within this field of nutritional neuroscience, what is really missing is medium to long-term RCTs. Like I said, we all know this is much, much easier said than done when it comes to this sort of work, but they are what is needed to really investigate the effect of these food groups on cognitive function. Finally, this has been touched on briefly throughout the past few days as well, but we notice a really stark lack of studies that truly consider more marginalized groups and real-life settings. And we know that this is an issue in research overall, so that is something that needs a lot more attention in the future, particularly if it wants to fulfill the goal of the Eat-Lancet reference diet being a global diet. So we'd just like to thank everyone who helped us write this manuscript, and big thank you to the ILSI for commissioning this piece of work in the first place. Up there we have everyone who was on our expert panel group. They were really, really amazing in helping us organize our thoughts and get through the writing process. And a special thank you to Sandrine Touré, Martin Vauquil, and Lucy Gertz, who headed this whole project with us. Thank you.